or multivariate double differentiation. So before that, let's see what is a kind of a 3D. So if I have a if I have a surface, okay, so I have a xy plane. So in the xy plane, this is x-axis and this is y-axis. Vertical is z-axis. So if I have set of points on the xy axis, so against each set of point there is a function fxy. And if there is a function, then there is a vertical. If I connect all the vertical points and in a kind of wire form, few of the vertical points in a wire form, it becomes a wire frame. If I connect all wire forms against a surface, then full 3D becomes a surface. Okay. And if I take all the points on the xy plane and compute the z axis and then connect all the z axis in continuous fashion, then it comes to a sphere. Or if I have a 3D like this and along z axis I make cut along z axis, okay, it is called cross section. Or each cross section, if I make a top view, then it is called contour. So these are the terminology that is used in 3D. Now, double differentiation in 3D. So if I have a function over x and y, then z equal to fxy. If z equal to fxy, then what is dz by dx provided y is constant? So this is x-axis where y is constant. This is x-axis where y is constant. This is x-axis where y is constant. This is y-axis where x is constant. This is, I mean, it looks orthographic. So this is y-axis where x is constant. If I take parallel to y-axis anywhere x is constant where there is a variation along y-axis. If I take x-axis anywhere y is there is a certain y and there is a variation along x-axis. So if I say dfxy by dx or dz by dx, then at any 2 point, if I take any 2 point at any y, any 2 point on x-axis, if I calculate z value, then what is the difference that comes in z value divided by the 2 points I have taken, dz delta z by delta x, where delta x tends to 0, then it becomes dz by dx. Okay, so per unit change along x-axis brings how many unit of change along vertical, that is dz by dx at particular y. Y is constant. Now this is y. Again, there is another y. This is y1. This is y2. At y2, again, I calculate dz by dx. So at particular y, what is dz by dx? This is called partial derivative. Partial derivative. Derivative means rate of change. How much it changes? If there is unit change along the independent variable, then how many unit of change that is seen independent variable? So dz by dx is variation along x-axis provided at any y is constant, then how much it is. So partial derivative along x-axis dz by dx, dfxy by dx. This is single derivation, fx x or dfx by dx or dz by dx. Suppose that fx xy comes, whatever I get, it comes as a function of y also. Like I have a equation called x square y, z equal to x square y. So fxy will be 2xy. It is so dz by dx equal to 2xy. If dz by dx equal to 2xy, then this value is a function over x and y both. If it is a function over x and y both, then dz by dx would vary at different x. So rate of change in z per unit change in x would vary if y changes and x changes. d fxy is x square y. dfxy dfxy by dx or fxxy equal to 2xy. If that is true, then whatever the derivative, partial derivative we are getting, it is a function over x and y both. So at different x, this value would change. At different y, this value would change. Okay. What is fxx xy? Double differentiation. fx xy. What is fx x xy? Or dy by dx of d fx xy. So if I have already have d fx xy, d fx xy is nothing but df d fx d double differentiation f x x xy is dy by dx of fx xy. fx xy is nothing but d fxy by dx or dz by dx provided at a particular y. So fxx xy is double differentiation along y-axis. What it is? So if I have fxxy as 2xy, this is what we calculated. fxy is x square y. Then fxxy is 2xy. If fxxy is 2xy, then I have now the change in z per unit change in x along x-axis. I know that is 2xy, but every x it is different. Okay. Now, what I'm going to calculate with double differentiation. So, first differentiation is the graph what we are getting. Graph value at two different x. Graph value along x-axis, if there is one unit change, then how much graph value would change? If along x-axis there is one unit of change, then how much the partial derivative or rate of change in z would change? Okay. So double differentiation is if I go along x-axis and there is a unit change along x-axis, then how many unit of changes it brings? I consider unit of change, but that is the rate of change. So how many unit of change that will be seen in the dz by dx, not in z, in the speed, in the velocity, in the rate of change of z with the x. So if I know along x-axis at each point what is the rate of change, then then how much per unit change along x-axis would bring change in rate of change. Earlier, one unit of change brings how much change in the graph value. Z equal to fxy. dz by dx we will calculate. Z is graph value. So one unit change along x-axis provided y is constant would bring how many unit of change in graph value. Now dfxx xy, one unit of change along x-axis would bring how much change in the rate of change in the graph. Okay, so that is along x-axis. So provided y is constant. So if we have 2xy and fxxy, then fxxxy would be 2y. Now it is only function of y. So at each y, the we can calculate, but it would not vary along x-axis. If I calculate f x x x triple differentiation, it would come as 0 because beyond that, if we calculate the rate of change, then there is no rate of change along the x. Twice it would change. First derivative, second derivative. What is f x y x y? Okay, if I know fxxy, then what is fxyxy? What is fyxxy? What is fyyxy? So these are the four things that will come. So fyy is same as fxx, is similar. So if I have a variation along y-axis, then per unit along variation when x is constant, per unit variation along y-axis would bring how much per unit variation along y-axis provided x is constant. So at each x variation along y-axis would bring how much variation in the graph value, that is fyxy. Fyyxy, double differentiation. Per unit change along y-axis brings how many, how much changes in the rate of change along y-axis. So we have calculated dz by dy earlier. So we have rate of change along y. If I have rate of change, I know that how much it is changing, okay, along y-axis. Then that change is how much it would change per unit vector, per unit change along y. That is double differentiation. Okay, so double differentiation as we have calculated, like if I have a ball and if I drop the ball, then first differentiation dy by dx tells that at each time gap there is a 1 second gap, 1 unit time. Consider 1 unit time is 1 millisecond. So 1 millisecond gap. If I take 1 millisecond, how much is the distance that is covered? So initially the distance covered is less. Start from zero, then more, then more, then more. Then if it goes to hit the ground, then at that time the distance covered per unit time is more. Means distance covered per unit time is changing. So velocity is not constant. If that is true, the change in distance, okay. So first distance is zero, then one, then next block of the time it is two, three. Suppose it is like this. Then how much change we are seeing? What is the gap? First is 1 and second is 2, third is 4, suppose. And first is 1, second is 4, third is 9, fourth is 16. Then per unit change in the time brings how much change in the distance, what you change in distance. Earlier the distance, now change in distance dx by dt. So first it is 1, then second is 2. So there is change in distance covered. So that is 1 at time 1. Now 2 and 4, difference is 2 at time 2. 4 and 9, difference is 5 at time 3. 9 and 16, difference is 7 at time 4. So this is d square x by dt. Whereas dx by dt is, we know at each time instance what is the distance. So how much distance covered? So first it would come as distance 1, 0, then second 1, 2, 3, 4, 2, 1, 4, 9, 16. This is the distance, this is dx by dt. But d2 square x by dt is what is the change in whatever we have seen now. So that calculates to acceleration. Similar to that, if we see fxxy or fyyxy, then how much fxxy, the first partial derivative, talks about the velocity, means how much difference that is seen in the graph value z dz by dx when there is 1 unit of change. Whatever the rate of change we saw now, that how much it changes per unit change along the x-axis. Double difference. Same as in y-axis. At one place y is constant, one place x is constant. So if I have z equal to x square by y, then dz by dx equal to 2xy. So first differentiation comes as variation is a function of x only. So d square z or d2z by dx square would come as 2y. Now it is not a function in x. If I differentiate further, it will come to 0. So now the change in graph value, change in graph value per unit change along x-axis, that is constant. for any particular y. What is f x y and what is f y x? So that we'll see. It is tough.